How to find intersection points using the graphical calculator. First of all, we will press 5, which is graphs. Then we will write in the two functions. So my first question is e to the power negative x and cosine x. We need to find the intersection points. First of all, we will press gsolve, then intersect, and now we have the intersection points. So my first intersection point at x is equal to 0. To find the other intersection point, you will need to press right. So my second intersection point is x is equal to 1.29265. We can use this way to find any intersection point between any two graphs. Another example, finding intersection point between the graph negative x squared plus 3x and 2x to the power of 3 minus x squared minus 5x. We will press gsolve, then intersect, and now we have the 2 points of intersection between the two graphs. And the last example of finding intersection points is 3x squared minus 1 and sine 2x. To find the area between two curves f of x and g of x, we will need to use the integration from a to b f of x minus g of x, where f of x is bigger than g of x. First of all, we have two equations, y is equal to x squared and y is equal to negative x to the power of 4. To find the area between them, we need to determine which function is bigger than the other function. As we see from the graph, x squared is the upper function and negative 2x to the power of 4 is the lower function. The question gave us that the limit is from negative 1 to 1. So it will be integration from negative 1 to 1 x squared minus which is plus 2x to the power of 4 dx. This will give us x to the power 3 over 3 plus 2 over 5 x to the power 5 between the limits negative 1 to 1. And now we will substitute the limits. And the answer is 22 over 15. To solve it using a graphical calculator, we will first press on F4, which is math, then the arrow, which is F6, and then the integration, which is F1. And then we will put in the function, which is x squared plus 2x to the power of 4 between the limits negative 1 and 1. And finally, we have the answer without the steps. Another way to solve this question is to use the limit from 0 to 1 and multiply it by 2. Since we have the two curves from negative 1 to 0 is the same as from 0 to 1. So we can use from 0 to 1 and multiply it by 2 and we will get the same answer.